For question 3F, we're looking at the limit as x goes to 0 from the positive side of sine x times 2x to the 14 plus 3x squared over cube root of x e to the x. Now, it doesn't look like there is some easy simplification of this, so we're just going to test for the L'Hopital's rules, the condition for L'Hopital's rule. So we're going to look at substitute 0 in, so we get 0 times 0 over the cube root of 0. So we have the condition that we can use to apply L'Hopital. So that's what we're going to do. We're going to apply L'Hopital's rule to this. So applying L'Hopital's, we're going to differentiate this, the numerator and the denominator, and see what happens. So we're going to have the limit as x approaches 0 from the positive side. It's going to be cos x times 2x to the power 14 plus 3x squared plus, using the product rule, sine x and 28x to the power 13 plus 6x. And then we're going to differentiate the denominator, and we're going to end up with 1 over 3 x e to the x, so differentiating the cube root, and then we're going to apply the product rule to that. So we're going to get 1 times e to the x plus x times the derivative of e to the x, which is e to the x. So there it is. There's our derivative. Sorry, I forgot the power on here. That's going to be negative 2 over 3. In fact, that negative 2 over 3 is significant because what that's going to do is it's going to put that factor in the numerator. So just rewriting this, I'm going to end up with the limit as x approaches 0 from the positive side. The 3 and the, just going to highlight there, this expression here, and that 3 is going to end up in the numerator. So we're going to end up with 3x e to the positive 2 over 3. And then we're going to end up with all that expression, cos x. I'm not going to simplify it because in the end, we're probably not going to have to simplify this because it looks like we have a factor of 0 in the numerator. Okay, so there's my whole numerator. And what's left in the denominator then is going to be just the bracket part here. Just going to highlight this. This is what's going to be left in the denominator. So we're going to end up with e to the x plus x e to the x. Now at this point we can plug in our 0. So we end up with when we evaluate this, we're going to end up with this equals 0 over, and then that e to the x is equal to 1. X e to the x is 0, so we end up with our limit is equal to 0. So this is one way we could do this problem. We can use L'Hopital's to do this. Now, I'm going to also show you an alternative here in that we could also do it by regrouping this and using a limit property to regroup this. So we're going to do this. Instead of doing it like this, we're going to group this, and I'm going to group the sine with the x, and I'm going to group this portion with the cube root e to the x. Okay, so then this portion is going to look like this, the limit. So I'm going to have the limit as x approaches 0 from the positive side of sine x over x to the power 1/3. And using limit properties, I can split this up from the limit as x approaches 0 from the positive side of 2x to the power 14 plus 3x squared. And that's going to be e to the cube root of e to the x is going to be x over 3. Okay, so then evaluating this limit, the green part of this limit really that's just going to end up being 0 over 1. So that's going to be equal to 0. For this portion here, I have the condition 0 over 0. So I have the condition for L'Hopital's. So I'm going to apply L'Hopital's. Okay, and then I'm going to end up with the limit as x approaches 0. I'm going to end up with cosine of x over x to the power of, 1/3, x to the power negative 2/3. That's going to end up in the numerator. So this portion ends up being the limit as x goes to 0 from the positive side. It's going to be 3x to the 2/3 times cosine of x, and this is going to become 0. Okay, so I end up with 0 times 0, so the limit is equal to 0. It's the same as the results I had before, but in this case, I'm not having to use, product rule to differentiate the numerator and the denominator. I've used limit properties to break up this limit into two separate limits and multiply the limits together.